Okay, so in your problem number 18, it is given period of oscillation of body of mass m1 is suspended from a light spring is T. Means when mass m1 is suspended from the spring, at that time period is T. Furthermore given if when body of mass m2 is tied to first body mass is m1. Now another body mass m2 is tied to it. So total mass will become m1 plus m2. So at that time its period will become 2. So now what we want to find out? We want to compare masses of m1 and m2. So I want to compare masses m1 and m2. How I can do this one? I have to relate mass with period. And for that purpose we have a relation. Omega square is equal to k upon m. So omega is equal to under root of k upon m. While omega is equal to 2 pi by t, which is equal to under root of k by t. Clear? So what I write? T is equal to 2 pi under root of k. My first mass is m1. At that time period is t. Second time what it becomes? Mass becomes m1 plus m2. At that time period is 2t. So period will become 2t and mass will become m1 plus. Now I will take ratio of equation 1 and ratio of equation 2. So taking ratio of equation 1 and 2. So I have taken the ratio of equation 1 and 2. So t factor will get cancelled. Here 2 pi will get cancelled. K factor will also get cancelled. And what is remaining? 1 by 2 is equal to 1 upon root m1 divided by 1 upon under root of m1 plus m2. So this factor will go to the numerator. So what it will become? It will become m1 plus m2 divided by. And now I can make squaring of both the sides. So if I make the square of both sides, square of 1 by 2 will become 1 by 4, which is equal to nothing but m1 plus m2 divided by. So it will become 1 by 4 is equal to 1 plus m2 upon m1. This 1 I have shifted here at the left side. So it will become 1 by 4 minus 1 is equal to m2 upon m2. If I solve this, LCM is 4. So what I am getting here? 1 minus 4 upon 4. Is it okay? So it will become as a m2 upon m1. So it will become minus 3 by 4, which is equal to m2 by. Is it right? So now I can make the inverse and I can find out the ratio. Clear? So that is nothing but the comparison of mass m1 and m2. Fine? Okay. Next. Now see the problem number 20. In that problem number 20, you have given two parallel SHMs. So you have given two parallel SHMs. Represented by, the first equation is represented as a x1 is equal to 5 sine 4 pi t plus pi by 3. 5 sine 4 pi by t plus, it is given pi by 3. And second, x2 is given as, you have given x2 is equal to 3 sine 4 pi t plus pi by 4. These are, you have given two SHM which are parallel to each other. They are superimposed on a particle. Means you have to do the composition of SHM. Determine the amplitude and epoch of the resulting SHM. You have to compare amplitude and epoch. Now if I compare this equation with your standard equation of displacement, x is equal to a sine omega t plus alpha. So this is my standard equation. To the standard equation. If I compare this first equation and then second equation. So if I compare first equation, what I get is amplitude of first acetone, that is A1, is equal to 5, and alpha 1, which is equal to 5. Now 5 what? You have to see that your SHMs are given here. So I'll say 5 as a centimeter. If I compare second equation, x2 equation, I am getting A2 is equal to 3 centimeter, and this alpha 2 is equal to nothing but alpha 4. So I am getting here values of A1, A2, alpha 1 and alpha 2. And using that, I can find out the resultant amplitude of SHM and epoch. Epoch means initial frequency. Now for resultant amplitude, we have a formula. R is equal to under root of A1 square plus A2 square plus twice A1 A2 cos of alpha 1 minus alpha 2. This is your formula. So I can use this formula, and by using this formula I can substitute the values of your A1, A2 which you have already written. A1 is what? 5. So 5 square is 25 plus A2. A2 is what here? 3. 3 square is 9 plus 2. Again A1 is 5. A2 is 3. Cos of, in bracket, alpha 1 is 5 by 2. Sorry, 5 by 3. Alpha 2 is minus 5 by 2. All values are the same. Now 25 plus 9. 25 plus 9 will be coming as a 34. So I'll write down 34 plus 2 into 5, 10. 10 into 3, 30. 30 cos of 5 by 3 minus 5 by 4. So here I have to find LCM. Here LCM comes 12. Means here I have to multiply by 4. So here it becomes 4 pi minus 3 pi. So 4 pi minus 3 pi is nothing but pi divided by 3 into 4, that is 12. Means pi by 12. Pi value is what? 80, 180. Is it right? So now here I write it is equal to 34 plus 30 cos of pi. Pi value is 180. 180 upon 12. So 180 upon 12. So what it becomes? It will become as a 34 plus 30 cos of 180 by 12. So here it becomes 12 ones are 12. 6 are remaining. So here it is 50. Is it right? So cos of 15. You have to see this value from the log book. Cos of 15 multiplied by 34. That value you have to see from the log book. Is it right? And then that will be multiplied with 30, added with 34, so that will give us a resultant as a R. And from that you have to find out the value of R. Clear? Then next is what? Determine the epoch. Determine the epoch. For epoch, now we are going to use a formula for your, I can say as a delta, resultant epoch. Resultant epoch is nothing but your delta. Delta is equal to tan inverse in bracket A1 sin alpha 1 plus A2 sin alpha 2 divided by A1 cos alpha 1 plus A2 cos alpha 2. You have to put the values. So what I will say here, it is equal to tan inverse in bracket A1 value is 5 sin alpha 1, alpha value is 5 by 3 plus A2 value is 3 sin alpha 2 value is 5 by 4 divided by, again A1 is 5 cos of 5 by 3 plus A2 is 3 cos of 5 by 3. And now you have to put the value. So what I write? Delta is equal to tan inverse in bracket 5 sin 5 by 3 Pi by 3 means nothing but your cos 60. Right? So what I say cos 60. Cos 60 is nothing but root 3 by 2. Right? Plus 3 cos 45. Sin pi by 4. Pi by 4 is nothing but 45. Sin 45 is 1 by root 3. Divided by 5 cos 60. Cos 60 is nothing but 1 by 2. Plus 3. Again cos 45. Cos 45 is 1 by 2. So it is equal to tan inverse. In bracket. Here what I say, it will be nothing but 2.5 root 3 plus 3. 1 by root 2. 1 by root 2 is nothing but 0.707. Divided by 5 by 2. 5 by 2 is 2.5. Plus 3. Again 1 by root 2. 1 by root 2 is nothing but 0.707. And now here I am going to multiply. So it will be become as a tan inverse in bracket 2.5 multiplied by root 3. Root 3 is 1.732. Plus by this 3 I can multiply here. So by this multiply here, so 3 7s are 21, 2 carry, so 2 I write here. Again 3 7s are 21. Divided by here 2.5, again their product is same, so 2.121. And now I can multiply here by this side. So this 2.5 into 2 means 25. 25 into 2, 50. 5 carry. 25 3s are 75. 75 plus 5, 80. 8 carry. 25 7s are 175 plus 7, 182. So 2 carry. Sorry, 2 I write. 18 carry. 25 1s are 25 plus 18. So 25 plus 18 is 35 plus 8. 35 plus 8 is nothing but 4.3. Right? So I will write down here 43. And decimal point I will shift by the 4 points. Plus 2.121 and this addition. So this addition 126.4. Numerator addition, it is equal to tan inverse in bracket addition will be coming here as a 0, 1, 4, 4, 6 divided by 4.621. Now see here, numerator is 6.4. Denominator is 4.6. Means this division is definitely greater than 1. If division is greater than 1, means what here I am getting tan inverse of 1 point something. Right? And all of you are knowing that tan inverse of 1 is 45. And 1 point something means your delta is definitely greater than 45. So do this division. After this division, you will get some value 1 point something. Of that, you have to find out the tan inverse angle, and that is nothing but your delta. But that value is definitely greater than 45. Clear? So like that manner, you can solve the sum of this composition of SHF. Okay, fine. Now the problem number 22. The problem which I have avoided, that is out of syllabus. That's why I have not taken that. Problem number 22. In problem number 22, you have to find out the number of oscillations performed per minute. You have to find out the number of oscillations performed per minute. Means you have to find out the frequency per minute. Frequency per minute by a magnet is vibrating. Problem number 22. Vibrating in a plane of uniform magnetic field. Uniform magnetic field V is given, which is equal to 1.6 into 10 raised to minus 5 Weber per meter. The magnet has momentum. Magnet has a momentum I, which is equal to nothing but 3 into 10 raised to 6. 3 into 10 raised to minus 6 kg meters. magnetic moment is mu, which is equal to 3 ampere meters. And what you want to find out? You want to find out the number of oscillations performed per minute. Clear? And we have seen the period of vibrating magnet, that T is equal to nothing but 2 pi under root of I upon M. Therefore, I can write frequency is equal to 1 upon 2 pi under root of mv upon r. So I'll first find out frequency per second and then I'll go for the frequency per minute. I'll put the values here. So it will become as a 1 upon 2 pi under root of m. You have given the m value. M means nothing but your, not m means here it is mu. Magnetic dipole moment. Mu notation. So mu is what? 3. B is 1.6 into 10 raised to minus 5 divided by I is nothing but 3 into 10 raised to minus 6. So this P3 factor will get cancelled. What I am getting? 1.6 upon 10 raised to minus 6. Minus 6 goes to the numerator. It becomes plus 6. So what it will write as? N is equal to 1 upon 2 pi. Under root of, here what is remaining? 1.6 into 10 raised to minus 5 plus 6. This minus 6 numerator, when it goes to numerator, it will become plus 6. So minus 5 plus 6 means it is 10 raised to 1. 10 raised to 1 multiplied by 1.6 means it is under root of 16. And under root of 16 means it is under root of 16 is 4. Therefore I get 1 upon 2 pi into 4. So it will be become as here 2 I am getting, so what I am getting 2 upon pi. That is nothing but the frequency. Is it right? But now what I want to find out? I want to find out frequency per minute. Frequency per minute means what I do? 2 pi into this 6. So 2 into 60 means it will become 120. 120 upon pi. So 120 pi value is nothing but 3.142. So if I do this division, forget about 143. If I consider only C, so 120 upon C means it is 40. But division factor is greater than 3. Means your answer is slightly less than 3. So that is nothing but your frequency per minute. Is it right? So this is your one of the numerical problem. So here I can say it is oscillation per minute. Is it okay? Fine. Now I will go for problem number 16. That is, at what distance from the mean position is the kinetic energy of the particle performing SHM of amplitude 8 centimeter 3 times its potential energy? So for this problem, I will just give the hint because this problem we have solved in MCQ and also the problem number 8 is same as that of this. What you are given kinetic energy is equal to 3 times potential energy. This thing will happen at what displacement? That is x you want to calculate. What you have to do? You have to put the value of kinetic energy when particle is performing SHM. So half m omega square in bracket a square minus x. This is your kinetic energy. It is equal to 3 times potential energy. 3 potential energy. Half m omega square. Clear? Now from both sides, what I am getting here, from both the sides, this half m omega square is a common quantity. So that quantity I will cancel out. So this quantity will get cancelled. What is remaining? A square minus x square is equal to 3x. So what I get it? 4x square is equal to a square. minus x square goes to the right side, it will become plus x square. So 3x square plus x square is 4x square. So 4x square is equal to a square, means what will say that 2x is equal to a, means x is equal to nothing but a by 2. And you have given in the problem, what is that? Amplitude is 8 centimeters. So 8 upon 2 means your displacement will get getting. Getting? Okay. Now, the problem number 17. A particle performing linear ascension of period 2 pi. So you have given particle is performing the ascension where its period t is equal to nothing but 2 pi. So period is given 2 pi. Which problem we are discussing? Problem number 17. What you are given further? About a mean position, O is observed to have a speed of b root 3 meter per second. So at mean position, speed which is maximum, which is equal to a omega, which is getting as a b root 3 meter per second. This is given data. If the particle is moving away from O means mean position, at that instant, find the time required by the particle to travel the further distance. So I want to find out if your particles start moving away from the mean position and it is covering a distance b. So how much time is required for that particle? That I want to find out. Clear? So now first I am getting this. A omega is equal to b root 3. If it is so, what I write here? A as it is. Instead of omega, I write 2 pi upon capital T, which is equal to b root 3. Omega value. Why? And why? What is time given here? Period given 2 pi. This here I'll put A 2 pi upon 2 pi, which is equal to b root 3. So 2 pi will get cancelled. So what I'm getting? Amplitude A is equal to b root 3. Now this amplitude value I am going to use in the displacement equation. So x is equal to a sine omega t. Now why I am writing only omega t? Because particle has started from the mean position. Now particle has started from the mean position, therefore displacement is x is equal to a sine omega t. So displacement, how much displacement I want? I want a displacement is equal to b. So I write instead of, in the place of x, I write b is equal to value of a, b root 3, sine of omega value 2 pi upon t into small. But you are knowing value of t is given as a 2 pi. So here I will substitute 2 pi. So 2 pi will get cancelled. B will get cancelled. So what I write? 1 is equal to root 3 sine of t. Means 1 upon root 3 is equal to sine t. Means I'll write down sine inverse of 1 by root 3 is equal to t. And 1 by root 3 is the value of which sine angle? That is sine 60. And sine 60, that I will write down as a pi by 3, which is equal to t. So your time required is nothing but how much second? Pi by 3. Clear? So here I have completed all the numerical problems. Each and every numerical problem I have taken here. So you have to go through everything. Watch the videos very carefully so you will get what modifications in the formula I have made wherever it is required. And remember all the formulas very carefully. So here your chapter as an oscillation is finished. Is it okay?